Good morning, welcome back. How are you doing today? I hope it is well and that you are ready to tackle some algebraic equations. So you've got your guided notes ready? Follow along and let's get going. As usual, we'll start off with some vocabulary. An algebraic equation is a statement that two expressions are equal. You've seen some algebraic equations before, and we talked about algebraic expressions just a little while ago. So for example, down here, 3x equals 27, this is actually an equation. We have an equal sign, an expression over here. It's a simple one, but 3x is still an expression, and 27 is also an expression. An equation is something that we can solve. We can figure out the value for x. Before, when we had just an expression, we couldn't find its value until somebody told us what size, what numbers to use for the variables. All right, pause the recording here for a second and try to solve these three equations. See if you remember how, and then come back to the recording. All right, so the first one, 3x means 3 times x equals 27. Of course, to undo the multiplication, we would need to divide by 3. And x becomes 9. And of course, we check that. When we say 3 times 9 is 27, then that works. X squared equals 169. Remember, to undo a square, we have to use a square root. So the square root on both sides, x becomes 13. Double check that, make sure that 13 squared gives us 169. And the last one, we have x plus 5, so we need to undo the addition with some subtraction. Remember, same thing to both sides. X is left alone on the left-hand side, and -7 plus a -5 should give us a -12. All right, not so bad. Of course, they get a little bit bigger, and that's why we're practicing this now. For example, we have 10m minus 4 equals 11. There's a multiplication here, there's a subtraction here. We know we need to undo them both, but which one should we undo first? Yeah, okay. So yeah, let's figure this out. And of course, if we have something much larger like this, my gosh, I don't even know where to start. And that's our goal today, to figure out where we start. So what we're going to do, as I scroll up here, is first just write down the steps, something so that you can have a reference. And then we'll go through a couple of examples and we'll try to highlight the steps as we go. Okay, so the first step here is to simplify. And what we mean by this is to simplify each side separately. We're not even going to try to move things around yet. We just want to get rid of some of the clutter. And so we do this by distributing and combining like terms. The key here is to look at each side separately. You already know how to distribute and combine like terms. We just have to make sure that we look at the left, clean it all up, and then look at the right and clean it all up. All right, after that, we need a goal, and our job is going to be to move all of the variable terms to one side of the equation. And as we do that, we'll then move all of the constant terms to the other side. It doesn't matter which side the variables are on and which side the constants are on. It just matters that we choose and that we separate them. The way we do this is by adding and subtracting things. Once we have all the variables on one side and all of the constants on the other, we're going to have something that looks like maybe 3x equals 27. And from here, we'll know what to do. We just have to divide. And what we do, of course, is divide both sides of the equation by that number that's in front of the x. And you'll remember that we call that the coefficient. And of course, that's of the variable term. And since these algebraic equations can get rather involved, it becomes more important than ever to check our solution. We check the same way we always have, by substituting the solution into the original equation. All right, so let's get started. It sounds like a lot, but it's really not so bad. I'll try to help you keep track of the steps as we go through. So let's start with the first one that we had written up above, 10m minus 4 is equal to 11. And we look at the left-hand side. Is there anything to distribute? No. Do I have any like terms that can be combined? No. M's are variable terms and constant terms, and they don't go together. And of course, the right-hand side, well, it's just 11, so there's nothing really to do there. So this very first step, to simplify, there's nothing for us to do. But just to make it nice and a little bit larger, I'm going to write the equation down again. Okay, so step 2. Our job is to get the variables on one side and the constants on the other. I'm kind of partial to having my variables on the left. It doesn't matter, it's just where I like them. And in this case, I have the variables on the left. There is a constant on the right, and this constant here, the minus 4 on the left, is the one that doesn't belong. All right, so what are we going to do? To move things around to different sides of the equation, we need to add or subtract. Since since our equation says 10m minus 4, we'll undo that subtract 4 by adding 4 to both sides. And when we say both sides, we mean both sides of the equation. And sides of the equation are separated, of course, by the equal sign. All right, so 11 plus 4 is what, 15? Equals comes straight down. A minus 4 and a plus 4 give me a big fat 0. And on the left side, 10m remains. All right, we're done. Variables on the left, constants on the right. Step number 3, we need to divide. Both sides by the coefficient on the variable term. And we look at this and we say, aha, I must divide by 10. And of course, we do this on both sides. Even though you know in advance that 10m divided by 10 will give you an m all by itself, write it down. If you only do it halfway, you're going to confuse yourself with what you see as compared to what you're thinking. 15 divided by 10, well, we should be able to do this in our heads, but just in case, divided by 10. Double check your mental math and make sure that your brain came up with 1.5 also. All right, let's see, last step, of course, is to check. And so we take this 1.5 and put it back into the original equation where the m was. All right, let's check. If we have 10 multiplied by 1.5 and then subtract 4, do we get 11? Yes, we do. This works, and we've found our answer. All right, let's try another. Maybe one that looks a little bit more involved. All right, step number 1 is to simplify. When I look at the left, is there anything I can do? I can. I can combine like terms on the left. Because I've got a constant for the 9 and I have another constant for the 11. And so that gives me 20. Bring everything else straight down. I look at the right-hand side. I have a variable term and a constant term. Those don't go together. They're not like terms. And that's what we're looking at. Okay, step 2. We want to get all the variable terms on one side, all the constant terms on the other. We're going to do this by adding or subtracting. I like my variable terms on the left. So I am going to move this one. This is a positive 10x. And what I'm going to do is subtract the 10x. I want to do that on both sides. And the whole point of doing that was so that the positive 10x combined with the negative 10x would give me a 0. On the right-hand side, don't forget about this negative over here. We have a negative 25 left over. On the left-hand side, 20 is still there. 5x minus 10x is a minus 5x. Okay, we're getting closer. Variables are on the left. This constant needs to move. I want the constants on the right. How can I do that? I can subtract it. Don't forget to do this to both sides. Right, this is a positive 20, so to make it go away, we will subtract 20. Both sides. Big fat 0 here. And bring down what's left over. Don't forget about this negative. Right, that's still there. So we have a negative 5x equal to, right, equals comes straight down. Negative 25 plus a negative 20 is negative 45. All right, now we're back into familiar territory. Step number 3 is to divide by the coefficient on the variable term. So here we want to divide both sides by negative 5. And what do we get? Well, negative 5 divided by negative 5 is 1. X is all by itself. Negative 45 divided by 5. A negative divided by a negative is a positive. This should be 9. All right, the last thing we need to do is check. And in this case, the left-hand side and the right-hand side are both a little bit involved. So we want to check them separately. Let's take the left and see what it's worth. We have 9 plus 5. Use those parentheses when you're substituting that value for the variable. So we have 9 plus 5 times 9 plus an 11. And let's see what that is. 9 plus 5 times 9 plus 11. 65. And then we do the same thing on the right-hand side. Pause the recording for a second, evaluate the right-hand side, see what you get. Come back when you're done. Your work should look like this, and on our calculator, we get 65 again, which is exactly what we wanted. We want these to match. Yay! Smiley face. And if they do, we've found the answer. X is now equal to 9. All right, let's try a bigger one. Flip the page. Don't get scared because I gave a whole page to this. I just couldn't fit 2 problems on one page, so I decided to leave lots of space for this problem. Okay, here we go. Step number 1, simplify. When I look at the left-hand side of the equation, is there anything that I can do? And, well, there's a lot of stuff I can do. The first thing is to distribute. All right, we want to say 5 times 6c and then 5 times 4. And that would give us, let's see, 5 times 6 is 30. So we have 30 c's. 5 times 4 is 20. We already have 7 c's there, but that's not being affected by the distributive property. And the right-hand side, 29c plus 74. All right, let's look at this again. Can I do anything else to the left-hand side? Oh, I can. I have some like terms. I see 30c and minus 7c. And that would give me, let's see, 30 minus 7, 23 c's plus 20. When I look at the right-hand side, I don't have any like terms. I have a variable term and a constant term. Those can't be put together. So we'll just bring the right-hand side straight down. Okay, now we're ready to go. This looks a little more like what we had on the last one. Step number 2, move all the variables to one side, all the constants to the other. And of course we do this by adding or subtracting. I am a creature of habit. I like my variables on the left. So I'm going to subtract the 29c from the right-hand side. Right, the 29c is positive. I will undo this by subtraction. Remember to line up your like terms. Whoops, hold on. Just helps to keep things organized. Right, big fat 0 right here. 74 remains on the right-hand side. The left-hand side, 23c minus 29c is a negative 6c. So, oh, we should probably keep our steps here. We subtracted 29c from both sides. All right, now we have to get rid of this 20. This 20 is positive. We'll undo it by subtraction. We don't want it on the left-hand side because the left-hand side is reserved for variables. Remember to do the same thing to one side that you do to the other so that you can see this big fat 0 here. 74 minus 20 is 54. All right, step number 3. You know where we're at now, don't you? We're ready to divide. What should we divide by? The coefficient on the variable term. We want that c all by itself. So we divide by negative 6. And of course we do that on both sides. I know, does it feel like I'm saying this all the time? I probably am, but that's because I've seen so many people try to keep things in their head and not write it down completely on both sides, and then they wind up making mistakes because they don't understand the next line that they've written. 54 divided by negative 6 is negative 9. All right, time to check this. Okay. So I can't see the top of my page, but you can see the top of your page, and I know it's there. So here we go. The left-hand side, let's see what it's worth. when c is equal to negative 9? We have 5 multiplied by, and then the parentheses, we have 6 times negative 9 plus 4. And then minus the 7c, and that c is negative 9. You can, of course, enter this into your calculator exactly the way that you see it. 5 parentheses, 6 more parentheses, negative 9, close parentheses, plus 4, close the other parentheses, minus 7, parentheses, negative 9. Right, the calculator knows what all the different parentheses are trying to tell it, and this comes out to be negative 187. All right, your job, evaluate the right-hand side, see what you get, and then come back. All right, your work should look like this. On the calculator, should look the same way that you wrote it on paper. We press enter, and whew, breathe a sigh of relief that we end up with negative 187 again. We are happy that these match. Yay! And this tells us that our answer is correct. And so way down here, c is equal to negative 9. Okay, let's do one more. Looks a little different than what we had before, but not too bad. We've seen expressions like what's on the left before. We've seen expressions that look like what's on the right before, so we know how to deal with these. The very first thing I want to do is make sure that I don't lose this negative sign here when I distribute. So I'm going to rewrite this equation as adding the opposite, that negative 1, so I can see the coefficient there and remind myself that I'm distributing a negative 1. Oh, and I'm going to shift this over, so hang on a second. There, that's better. Okay, here we go. Step 1, simplify. We look at the left side, we look at the right side. So the first thing we'd like to do is distribute, because we can see that. And distributing is just plain fun. Right? The negative 1 multiplies by the 4y and by the 6. The 3 will multiply by the 7 and the negative 2y. And so we end up with y minus a 4y. A negative 1 times a negative 6 gives positive 6. 3 times 7 is 21. 3 times negative 2y is minus 6y. And then bring down the plus 9. Okay. Wow, we've got a lot of like terms to combine, don't we? Remember that we need to look at the left separate from the right. All right, take a second, pause the recording, combine the like terms on the left, combine the like terms on the right, and see what you get. Your line should look something like this. Actually, it should look exactly like this. Y minus 4y is negative 3y. 21 plus 9 is 30. And all of the things that are not like terms just come straight down. All right, step number 2, add or subtract. Change colors here. I like all the variables on the left, so I'm going to move my variables on the left. What should I do here? How am I going to move this negative 6y? Yes, add 6y. And where am I going to add this? To both sides. Nice big 0 over here. Bring the 30 straight down. Negative 3y and a positive 6y gives me a positive 3y. This 6 needs to go. How do I move it? I subtract it. Where do I subtract it? On both sides. Keep that equals in the middle. So 30 minus 6 is 24. A positive 6 and a negative 6 make 0. And we are left with 3y equal to 24. All right, time to divide. By the coefficient, which is 3, on both sides. I know, you're getting tired of me saying that. But hopefully it will help you remember. 3 divided by 3 is 1. Y is equal to 24 divided by 3 is 8. Last thing, of course, we need to do is to check. So pause the recording, check both sides. Check the left side, check the right side, and then come back and see how your work compares to mine. Your work for the left side should look like this. On your calculator, it should type the same way that you wrote it, and we end up with negative 18. On the right-hand side, your work should look like this, and of course we type it in the way we see it on the paper on your calculator, and still come up with negative 18. These match. We know that our solution is correct, and y is equal to 8. Okay. So now we're pretty good at solving some equations. We're pretty good at evaluating expressions. We're pretty good at simplifying expressions. We know how to use the distributive property and how to combine like terms. What we need to be able to do is get the equation onto the paper, because nobody's going to give it to us. It's going to come from a situation. All right, we have looked at words that indicate addition or subtraction or multiplication or division. We're just going to look at them again and try to put them together so that we have perhaps some larger equations. The only word that really gives people a lot of trouble is than. When we see an expression, a phrase, something like 7 inches taller than, right? The taller is telling us that we need to add, but the than part says we need to use this second. So really, we start with y and then add the 7, taller than. So we put that in second. 12 pounds lighter than x, right? Lighter tells us we need to subtract, but it's the than that says we need to use this second. Right? We start off with x, and then we got 12 pounds lighter. Since we have equations now, we have to worry about what translates into equals, and that's usually is, or some other variation of is, like was, were, has, will be, gets, becomes. All right, let's see what we can do. Let's try some small ones here. The length of a concrete slab is 18 inches longer than the width. And this one we can translate fairly directly. The length of a concrete slab, length, let's just call that L, is, that's equal, 18 inches longer than. So longer tells us we have to add, and the than says it has to come second. Longer than the width. That's the first piece. Just like that. All right, you try the next one. Let G be George's paycheck, and let C be Carl's paycheck. Pause and come back when you're ready. All right, let's give it a try. George's paycheck. That's G. Was. That's our equals. $75 less than. So we know we need to subtract, and it needs to come second. Carl's paycheck, C. Not so bad, huh? Okay. Sometimes the sentences don't translate quite as directly, and it's never a bad idea to tell people what your variables represent anyway. Fred's truck has 3 times as many miles on the odometer as Max's truck. So if you wanted to let F represent what's happening with Fred's truck, we should probably tell somebody that this is actually miles. And while we're at it, let's let M be the miles on Max's truck. So when we say Fred's truck, what we really mean are the miles on Fred's truck. Has, that's our is, our equals. 3 times, well, that's pretty easy. Let's multiply something by 3. As many miles on the odometer as, and so we want to talk about the miles on Max's truck. And there we go. That's it. When you are looking at formulas and equations, sometimes we have 2 values for the same type of thing. In this case, we have a first voltage and a second voltage. So we can't really use V to talk about voltage because we wouldn't know which one. And so what we do is use a subscript, V sub 1. This will be the first voltage. And V sub 2, that will be our second voltage. We see a lot of these subscripts as we watch quantities change over time as well. You've probably seen the pressure equations and temperature equations with subscripts in them already. Okay, so here we go. The first voltage is, first voltage, that would be V sub 1, is equals 3 volts fewer than, you write it. 3 volts fewer means I need to subtract. Fewer than means I need to have that subtraction happen second. Twice means we're multiplying by 2. 2 times the second voltage. 2 times V sub 2. So writing neatly matters. You don't want to make this look as if you are multiplying by 2 twice. That subscript is just to help you keep the voltages separate from each other. Okay, next page. Some situations require us to combine equations. We will have a main equation and a mini equation. What do I mean by that? Well, let's see. Bush received 202 fewer electoral votes than Clinton. We need to write an equation representing the total number of votes. Sorry. I'm stuck on the last problem. Anyway, total number of votes. That's going to be our main equation. But we've got more information here about one of our candidates. That's going to give us a mini equation. Here's what I mean. Let's let B talk about the Bush votes. And let's let C talk about the Clinton votes. This line right here is going to give us that mini equation. Bush received, so that's B, equals 202 fewer electoral votes than Clinton. So I need to subtract the 202, and it needs to come second. And there we are. So this is an equation I get from the information, but it doesn't actually do what they asked me to do. My main equation should be about a total. Bush votes plus the Clinton votes will give me a total. So my main equation is, how do I create that total? B plus C is equal to T. But I have more information than just this. Let me change colors here. I know something about B. So I want to put that extra information into my equation. Instead of B, I want to use all of this. Everything else stays the same, but I had more information about the Bush votes, so I want to use it. When I look at this, on the left-hand side, I see some like terms I can combine. So I'd like to simplify it. 1C plus another C gives me 2C's minus 202, and that should equal my total. All right, we should probably try this one more time, and then we'll call it good for the day. The heater's value is 7 times the air conditioner's value. We need an equation for the total value. So total tells us we're going to add. We want to add the heater's value to the air conditioner's value, but I have extra information about the heater's value that I want to incorporate. Let's start by defining our variables. H will be, of course, the heater's value. A will be the air conditioner's value. This information about the heater is going to give us a mini equation. The heater's value, that's H, becomes our equals 7 times, I have to multiply, 7 times the air conditioner's value, 7 times A. Right, the heater is more expensive than the air conditioner. Our main equation is the one that talks about the total. So the heater's value plus the air conditioner's value will give us the total. Okay, heater's value, that's H, plus air conditioner's value, that's A, equals the total, we'll call it T. But I had that extra information about the heater. The heater is equal to 7 A's, so I would like to incorporate that into my main equation. So we take 7A and substitute it for the H, because I know that those two things are equal. And after that, we simplify. 7A plus an A gives us 8A. And of course, the total is whatever the total is. We can't do any more with this because we don't have any values to use. Doing more with this is what we will do on the next lesson. All right, good luck with your homework. We'll be talking. Bye-bye.